So this video goes through the review sheet. You can also find the key for it just on the review page on Canvas. Things that I would have out as you're working on the review sheet on your note card, obviously your notes, your lab, and then your problem set. I also have here the article that we read on gravity. And you can find this on the class log. There's an electronic file for it too. So see right here that about 60% of your tests are going to be questions on gravity, both what it is, so its definition and what influences it, and the equation. And then 40% are going to be on Kepler's laws and vocabulary about orbits and ellipses. So if you first look through and see all the vocabulary, if you feel like you understand that word and know what it is, then you don't need to add it to your note card. But if you're not sure about it, that's something you should add. The lab has the majority of definitions, and your notes has a few of them as well. So orbit is just a word that refers to the circular path an object takes around another in space. So we don't refer to orbits that happen like on our planet, but the Earth orbits the sun, or the moon orbits the Earth. And remember, the shape of the orbit is an ellipse. It can be very close to circular, or it can be more oval. But both of these things would be orbits, and the shape is the ellipse. Most planets have very small eccentricities, and their ellipse shape is pretty circular like planet Earth. But then as planets get farther away from their sun, like Pluto, sometimes it can have more of an eccentric orbit. So eccentricity is a measurement of how oval an orbit / ellipse is. So usually these numbers are low, like 0.01 or 0.1. And to refresh your memory on that, you can take a look at the lab, and there's a couple different charts. There's this one that has the orbital eccentricity here of all the different planets in our solar system. So you can see the biggest one is Mercury here at 0.2. But then many of them are very, very small. And so Pluto has even the biggest, because it's the smallest kind of planet. Sadly, not really a planet anymore. But you can see that Pluto has the highest at like 0.26, 0.25. And Mercury's pretty high, but all the other planets are very, very small. So eccentricity is just a measurement of how oval it is, and usually low, very small numbers. So if we look at some of these other vocabulary words, radius is r in the equation. And remember, it's not always the radius of a circle. Really, it's the distance between two centers of mass. So if we have two planets here and we're trying to calculate the distance between them, oops, pretend that goes to the exact center. It's from the centers. If we were calculating the gravity between these two. If we were calculating, though, the gravity between you standing on planet Earth, then it would just be the radius of Earth, of the circle. So just be careful. It's not always the radius of a circle. Truly, it's the distance between the two centers. So a focus, there are two of these points in an ellipse, and the sun is at one of them. So remember in the lab, the first part that you did, Law 1, you had two different focuses, and those were your push pins. And then the string you used around the push pins to help create the shape of the ellipse. So the distance between the focuses, or the foci, does influence the eccentricity and shape of an ellipse. But really their definition is just that there are two of these points, the sun is at one of them. And you could also say they're on the major axis, the center line. So maybe there and there are the two focuses, two foci. Foci is just plural of focus. So that brings us to the major and minor axes. And these might be easier to draw a picture. So the major is the bigger horizontal, and the minor is the vertical. When we talk about the semi-major, it's just half. A semicircle is a half circle, semi means half. So half, let's see if I have another pen here. So this distance right here would be the semi-major axis. And this distance, the semi-major axis, does have a lot of implications for Kepler's laws, and it is pretty important. So the major axis is talked about much more than the minor. The period is just the time it takes for an object like a planet or a moon or a comet or something to travel one lap. And it could be one lap around the sun, but if we're talking about the moon's period, we could talk about one lap around the Earth, really just one lap around whatever it's orbiting. But usually when we're talking about period, we're talking about planets, and we're talking about them going around the sun. So for Earth, this is just 1 year. And we compare all the other planets to Earth. Remember that the period is really important and comes into play in Kepler's third law here. And so the orbital period is always put in years. So Earth is just 1, but then we can see they can get huge for planets that have a very large semi-major axis. So again, these vocab words, if you do not have them, if you don't understand them, if you're not sure about the definitions, add them to your note card. Now the equations and constants, you only need Newton's law of gravity. So you only need this formula. Make sure you know G, 6.67 times 10 to the negative 11th, so that very small number, and make sure it's put into your calculator too. And if it's not on the test, just ask me and I can help you do that. That is the only equation you need. But other constants are that you need the information about Earth. And so the mass of Earth and the radius of Earth, you need to write down these two numbers on your note card. Because many times a problem won't actually tell you what those things are.